Hello, everyone, how are you? In today's video, we are going to talk about the history and evolution of computers, from the first calculating devices to the modern smartphones and supercomputers. Did you know that the first large-scale electronic digital computer in the world was created in 1946 and had almost 18,000 vacuum tubes? And that nowadays there are quantum computers that can perform much more complex and faster operations than conventional computers? So, stay tuned and follow this amazing journey through computing technology. The word computer comes from the verb to compute, which means to calculate. Therefore, we can say that the origin of computers is related to the human need to count and perform mathematical operations. One of the first computing machines was the abacus, a mechanical instrument of Chinese origin created in the 5th century BC. The abacus is considered the first computer, as it is able to perform simple algebraic operations, such as addition, subtraction, multiplication, and division. In the 17th century, the first automatic calculating machines appeared, which used gears and toothed wheels to perform the calculations. One of the inventors of these machines was the French mathematician Blaise Pascal, who created the Pascaline, a mechanical calculator that could add and subtract numbers of up to 8 digits. Another inventor was the German mathematician Gottfried Wilhelm Leibniz, who improved the Pascaline and created the first machine capable of multiplying, dividing, and extracting square roots. Leibniz also developed the first modern binary number system, which is the basis of the logic of current computers. In the 19th century, the English mathematician Charles Babbage designed an analytical machine, which would be the first programmable computer in history. Babbage's analytical machine was composed of 4 parts: the mill, which was the processor, the store, which was the memory, the reader, which was the input device, and the printer, which was the output device. The analytical machine could perform any type of calculation, as long as a set of instructions, called a program, was provided. These instructions were inserted into the machine by means of punched cards, which were a form of data storage. The analytical machine was never fully built, but it is considered the precursor of modern computers. The first generation of computers emerged around 1940 and lasted until 1956. The operation of these computers was based on vacuum tubes, which were electronic components in the shape of a lamp, responsible for amplifying or modifying an electric signal. The first computer of this generation was the ENIAC, Electronic Numerical Integrator and Computer, which was created in 1946 by engineers John Presper Eckert and John William Mauchly. The ENIAC had almost 18,000 vacuum tubes, occupied an area of 167 square meters and weighed about 30 tons. It was capable of performing 5,000 operations per second, but could only execute one task at a time. The ENIAC was used for military purposes, such as calculating projectile trajectories and testing atomic bombs. Other computers of the first generation were the UNIVAC I, Universal Automatic Computer, which was the first commercial computer in history, launched in 1951, the EDVAC, Electronic Discrete Variable Automatic Computer, which was the first computer to use the concept of stored program, that is, the program and the data were in the same memory, and the IBM 701, which was the first computer produced on a large scale by IBM, in 1952. The computers of the first generation were programmed in machine language, which is a low-level language, composed of sequences of 0 and 1. The input and output of data were done by means of punched cards, magnetic tapes or switch panels. The second generation of computers emerged in 1956 and lasted until 1963. The advance of this generation was the replacement of vacuum tubes by transistors, which are electronic components capable of amplifying, controlling, or switching electrical signals. The transistors were invented in 1947 by physicists John Bardeen, Walter Brattain, and William Shockley, who received the Nobel Prize in Physics in 1956 for this discovery. The transistors allowed the reduction of the size, power consumption and cost of computers, as well as increasing the speed, reliability, and memory capacity. The computers of the second generation could perform tens of thousands of operations per second and could execute more than one task at the same time. Some examples of second-generation computers are the IBM 1401, which was the first computer to use alphanumeric characters, in 1959, the PDP-1, Programmed Data Processor, which was the first interactive computer, in 1960, and the Atlas, Automatic Computing Engine, which was the first computer to use virtual memory, in 1962. The computers of the second generation were programmed in assembly language, which is a low-level language, composed of mnemonic symbols that represent the machine instructions. The input and output of data were done by means of peripheral devices, such as keyboards, monitors, printers and magnetic disks. The third generation of computers emerged in 1964 and lasted until 1971. The progress of this generation was the introduction of integrated circuits, which are sets of transistors and other miniaturized and interconnected electronic components on a single silicon wafer, called a chip. The integrated circuits were invented in 1958 by engineer Jack Kilby, who received the Nobel Prize in Physics in 2000 for this invention. The integrated circuits enabled the further reduction of the size, power consumption and cost of computers, as well as increasing the speed, reliability and memory capacity even more. The computers of the third generation could perform millions of operations per second and could execute several tasks simultaneously. Some examples of third-generation computers are the IBM 360, which was the first computer to use a standardized hardware architecture, in 1964, the UNIVAC 1108, which was the first computer to use a multi-programmed operating system, in 1965, and the DEC PDP-8, which was the first small-scale commercial computer, in 1965. The computers of the third generation were programmed in high-level languages, which are programming languages closer to human language, such as COBOL, Fortran, Pascal, and BASIC. The input and output of data were done by means of peripheral devices, such as keyboards, monitors, printers, and magnetic disks. The fourth generation of computers emerged in 1971 and extends to the present day. The advance of this generation was the creation of microprocessors, which are integrated circuits that contain all the essential elements of a computer, such as the central processing unit, CPU, the memory and the registers, on a single chip. The microprocessors were invented in 1971 by engineers Federico Faggin, Ted Hoff and Stan Mazur, who worked at Intel. The first microprocessor was the Intel 4004.
That had a processing capacity of 4 bits and a frequency of 740 kHz. It was used in calculators, clocks and other simple electronic devices. The microprocessor enabled the miniaturization and popularization of personal computers, which are computers for individual use, portable and affordable. Personal computers revolutionized computing, communication, education, entertainment and society in general. Some examples of fourth-generation personal computers are the Altair 8800, which was the first personal computer marketed kit form, in 1975, the Apple II, which was the first successful personal computer, launched in 1977 by the company founded by Steve Jobs and Steve Wozniak, the IBM PC, which was the first standardized personal computer, launched in 1981 by IBM, and the Macintosh, which was the first personal computer to use a graphical interface and a mouse, launched in 1984 by Apple. The personal computers of the fourth generation were programmed in high-level languages, such as C, Java, Python and Ruby. The input and output of data were done by means of peripheral devices, such as keyboards, mice, monitors, printers, hard disks and CDs. The fifth generation of computers is a projection for the future of computing, which involves the development of new technologies, such as artificial intelligence, parallel computing, distributed computing, cloud computing, quantum computing and biological computing. Artificial intelligence is the ability of computers to simulate human reasoning, learning and creativity. Parallel computing is the ability of computers to execute multiple tasks at the same time, using multiple processors or cores. Distributed computing is the ability of computers to communicate and share resources on a network. Cloud computing is the ability of computers to store and process data on remote servers, accessible by the Internet. Quantum computing is the ability of computers to use the principles of quantum mechanics to perform operations much faster and more complex than conventional computers. Biological computing is the ability of computers to use organic materials, such as DNA, to store and process data. Some examples of fifth generation computers are the Google Brain, which is a research project in artificial intelligence, started in 2011 by Google, the Watson, which is a cognitive computing system, capable of answering questions in natural language, developed by IBM in 2011, the Wave, which is the first commercial quantum computer, launched in 2011 by the Canadian company The Wave Systems, and the DNA storage, which is a method of storing data in DNA molecules, developed by researchers from the University of Washington and Microsoft in 2016. The computers of the fifth generation are programmed in high-level languages, such as Python, R, MATLAB and hashtag. The input and output of data are done by means of peripheral devices, such as keyboards, mice, monitors, printers, hard disks and pendrives. Well, folks, that was our video about the history and evolution of computers. I hope you enjoyed it and learned a little more about this fascinating area of technology. If you liked it, leave your like, comment and share and subscribe to the channel. See you next time.